Hello guys, welcome back to my YouTube channel. Today we are going to look at the equation of a circle, okay? On the board before us we have a circle with a center, okay? With this as the center. Hope that is correct. So a circle essentially is a shape that is defined by the center and of course the circumference. So what I'm going to do here today is to derive the equation of a circle in three forms. We have one, the standard form, then the equation of a circle when center is at the origin, okay, and then we have the standard form of an equation, and then we have also the general form of the equation of a circle. Okay, so these are the three things we are going to be looking at. So since we have this circle located within the quadrant in a Cartesian coordinate system. So what I'm going to do now is to, first of all, this circle has a center, and the center is at point H and K. Now from the center I'm going to draw a radius. This is the radius from and then at the point here, point P, coordinate X and Y. The coordinates of this point P on the circumference is XY. As coordinates, let me make that big. Coordinate X and Y. Okay, so we are going to look for the equation of this circle. In order for us to do that, I'm going to draw a line. That's another radius. But what I'm going to do is that, let me redraw this so that, okay, the point P is at this edge here. The point P is at this edge and has coordinates X, Y. And then of course I'm going to extend this another line, okay? And then we have an angle in between. So from point P, I'm going to draw a line. Let me call this, this is point C. This point P, let me say this is point, let's say point B, okay? So we have PCB or PBC, whichever way you want to look at it. Then from point P, I'm going to draw a perpendicular line. A line that is perpendicular to line CB or BC. So we have this angle 90 here. So I'm going to call this N. Okay? So what I'm going to do is also, I'm going to, this is point X. So I will extend this line. And then of course, this is point H. I will extend this line. So from here to this point, the distance is X. Okay? And then from here to that point, the distance is H. So that this distance, the distance between C and N is X minus H. Okay? The distance from C to N is X minus H, which is the same as what we have here, X minus H. Okay, so we also have to extend this and call this K, and then of course we extend this also and call this Y. So the distance from here is Y, this is Y, and then of course this is K. So that this distance here will give us Y minus K. And this distance is also comparable to what we have here. So this point will be, the distance here will be y minus k as well. Okay, y minus k. Okay, that's where we have it. Y minus k. Good. And then of course, these are radius. So I'm going to bring out this triangle. I'm going to look at this triangle, and then we derive the equation of this circle using two methods. We're going to have two methods. So we have method 1. Method 1 will be trigonometry. We are going to use trigonometry. Trigonometry. Okay? So now, from trigonometry, we have sine theta. Of course, we know that sine is opposite over hypotenuse. So we have the opposite is y minus k all over r. K. Then of course we have cos theta. Cosine is adjacent over hypotenuse, which will give us the adjacent is x over h. Sorry, x minus h over r. So I'm going to call this, let's call this 1, and we'll call this 2. So from 1 and 2, before that, there is this identity. There is this trigonometric identity where we have from trigonometry, we have it that cos square theta plus sine square theta equal to 1. And we know that the meaning of cos square theta is cos theta squared. And the meaning of sine square theta is sine theta all squared equal to 1. So cos theta is x minus h over r all squared plus sine theta is y minus k over r all squared equal to 1. So what I'm going to do now is I'm going to rewrite this expression to give x minus h squared all over r squared plus y minus k squared over r squared equal to 1. So the LCM is r squared. So we multiply each of the terms, each term in the equation by r squared. So we have r squared dot x minus h all squared over r squared plus r squared dot y minus k all squared over r squared equal to r squared dot 1. That's r squared multiplied by 1. So the r squared and this r squared will cancel each other out. Same thing happens here. So we have x minus h squared plus y minus k squared equal to r squared. That is r squared multiplied by 1. So from here, we'll just simply expand this. Just expand that plus y minus k, then y minus k equal to r squared. So I'm going to come over here to expand that. Don't forget, this method is using trigonometry. Using trigonometry, we can now further expand that to give. So once we expand this bracket, we are going to get x squared, that's x multiplied by x, then x multiplied by minus h will give us, this is x squared minus xh, the same thing, minus h times x, that will give us another minus xh, and then of course finally we have h squared. Plus, we do the same thing to this, we have y squared minus yk minus yk plus k squared equal to r squared. So what I'm going to do now is to bring this and this together. So I have x squared plus y squared. Then this will give us minus 2hx plus minus 2ky. Okay. Then we have plus h squared plus k squared equal to r squared. Right? Good. So from here, we are going to have h squared and k squared move to the right hand side. Okay, so we have x squared plus y squared minus 2hx minus 2ky equal to r squared minus h squared minus k squared. Okay, so we have this. Now we are going to do a kind of substitution. Don't forget that h and k are the centers. Okay, so we are going to introduce a new set of centers, g and h. In that case, I'm going to say let g equal to minus h and f. That's g and f we are introducing. So g will represent minus h and f will represent minus k. Okay, minus k. And then this is a constant. R squared minus h squared minus k squared will be regarded as constant, and then we represent that as c. Will be r squared. I mean, we are introducing a new set of constant now. That's another constant that will replace r squared minus h squared minus k squared. So we have r squared minus h squared minus k squared. So this equation, this particular expression, this equation now becomes a squared plus y squared. So, and then minus h. So this will become plus 2gx. And the whole of this now becomes plus 2fy. And then equals to c. That is for the whole of it. And then we have x squared. So to write this now in the okay, so I think there's a mix up there. This is actually the standard form. Okay, this is the standard form of the equation of a circle. So I missed that out. So this is the standard form of the equation of a circle. And then what I'm now doing is to derive the general form. Okay, so I'm deriving the general form. So I'm going to go back and show us the form when you have, when the center is at the origin. Okay, so I'm going to get back. So this is the standard form. Let me quickly correct that. This is the standard form of the equation of the circle. So what we are doing now is to derive the general form. So deriving the general form is just trying to expand this and solve it algebraically. Okay, and then let's continue with what we are doing. So from here we have y squared plus 2gx plus 2fy minus c equal to 0. So this gives the general form. This is the general form of the equation of the circle. Now let's try to show when the center of the circle is at the origin. When the center of the circle is at the origin. So what happens? That means when the center of the circle is at the origin, that means that the hk will be equal to 0, 0. Okay, so in that case, so from the standard form now, here's the standard form. From the standard form of the equation. x minus h squared plus y minus k squared equal to r squared. So we have it that h equal to 0 and k equal to 0. So what happens is that this becomes x minus 0 all squared plus y minus 0 all squared equal to r squared. So x minus 0 is x, so we have x squared plus y minus 0 is y, then we have y squared equal to r squared. So this is the form when the center of the circle is at the origin, okay? So that is where that's how to derive the equation of a circle. So the second method, which is method 2, that we use Pythagoras theorem. Pythagoras rule or theorem. The Pythagoras rule or theorem. So where we have, let me quickly bring out that right angle triangle that we drew earlier. Where this is the r and this is y minus k, and then here you have x minus h. Because we have the angle. So from here, this is the hypotenuse, this is the hypotenuse, this is the opposite, and this is the adjacent. So the Pythagoras rule states that the opposite squared plus the opposite squared plus the adjacent squared will give us the hypotenuse. Give us the hypotenuse squared. Okay? So if that happens, that means that the opposite squared will be this is the opposite squared will be y minus k all squared plus y minus k all squared plus x minus h all squared equal to r squared, and which we can rewrite as x minus h all squared plus y minus k, yes, k all squared equals to r squared. So that is where we have the standard form of the equation of the circle. That's the standard form from Pythagoras rule. I'll see you in my next class where I will show you how to solve problems relating to circles. Please like my video, subscribe, and give me a thumbs up.